Air is a part of our atmosphere we can see, we can feel. Not directly, we cannot see it directly, but we can feel the air. We breathe in air, right? And this air, in this short episode, we are going to be talking specifically on air. Now, this air consists of different substances, and these include nitrogen, carbon dioxide, noble gases, and most importantly, oxygen. The reason why I said most importantly oxygen is that oxygen is a part of the air that is combustible. Oxygen is part of the air that we breathe in, and I will describe a simple experiment used to demonstrate the fact that oxygen is combustible. And now that combustible part of the air, we will use that experiment to describe the percentage of oxygen. So, for example, when you have a setup like this, when you have a graduated glass cylinder, a glass tube that's graduated. So when I say graduated, I mean that there are markings representing the volume. So in these markings, whenever you have it inside another tube, another dish of a substance, when you fill this graduated tube with water and then invert it and put it inside another tube of water, and then finally you adjust the levels of the in the two tubes so that they are approximately equal. Then you take a phosphorus, a smoldering phosphorus. So basically, phosphorus that is burning in air is known as smoldering phosphorus, and then you bend it into this glass graduated tube. So after some time, after the phosphorus, the stick of phosphorus has burnt, because that phosphorus will not burn forever. It will burn for a limited amount of time, because this graduated tube, there's a volume of air in this graduated tube. So when the combustible part of the volume of the air has been used up, the phosphorus stops burning. So you can basically calculate the combustible part of the air by subtracting the initial volume in the graduated tube from the final. So you subtract the final from the initial. So when you do that and you take the percentage in terms of the initial, you are going to see that your answer should be close to 20%. So this experiment is often used to show that the relative amount of oxygen in the air is 20%, or rather 21%, approximately between 20 and 21%. So other components, other non-combustible components include nitrogen. Nitrogen is about 70% in the air. Then carbon dioxide is about 0.03%. And now carbon dioxide is kind of like the the epicenter of activities involving global warming, because carbon dioxide is anytime you have just a little imbalance in it, you can cause the greenhouse effect. Then you also have noble gases. So all these ones I've listed, they are all non-combustible. It's only oxygen that is combustible in the air. Now, speaking further on oxygen, in this air, oxygen can cause different reactions. So whenever you expose different substances to air, you can have different reactions. And to add, there's also what is known as water vapor in air. There's a particular extent of water vapor in air, and it is this water vapor that is in air that react with other elements like sodium hydroxide. Yes, sodium can react with the water vapor in air to form sodium hydroxide, and then can also react with the carbon dioxide in air to form sodium trisulcarbonate. So, and these are examples of reactions which can occur when you have chemical substances exposed to air. And lastly, we also talk about the flames. Now, whenever not just chemical substances, you can also have materials exposed to air, and whenever these are exposed to air, they undergo what's known as combustion. And I will leave you today with the knowledge that anytime you have a luminous flame always involves that element. So, and then a non-luminous flame is the hottest part of the flame, while the luminous flame involves the unburnt particles. For example, whenever you have a candle flame and this is exposed to air, and then the wick of the candle, you have different regions of the flame. So at the base of the flame, you have the place where there's complete combustion, because the reason of that is that the rushing of air causes the air to be the particles at the base to experience complete combustion. Then you have in the interior of the flame, you have the non-luminous part of the flame, and then at the exterior you have the luminous part of the flame. So these are just the different parts of the flame which are classified based on the exposure to air. So whenever you have a lot of air in the flame, you have a non-luminous flame. Whenever you have not enough air, or when you have a lot of the unburnt particles, it's known as a luminous flame. So in summary, we talk about the composition of air and the reaction of air with different substances, and we'll talk about the combustion of things in air and types of flame that results from those combustions. So thank you for watching.